Hello all. This is an actual interview question that I faced. In this video, this is the plan. We'll first try to discuss the interview question, that is delete duplicates, and next see the solution that I gave in the interview. And during that time, why did I think the solution that I gave shouldn't have worked? But why is it working anyway when I came back and checked with the same logic? So these are the points that we'll be seeing. Coming to interview question, we have a table like this, two columns and some duplicate rows. We have to delete these whatever the rows that are duplicated with just having a single row. For example, we have this data subset, we have three duplicates, we only need one, delete the other two. Same here, delete one, keep one. Okay, so during that time what I thought was, we have duplicates. Whenever we have duplicates, we should come up with a logic which separates the row that we wanted to the rows that we don't want. One such way is try to assign row numbers for these things, grouping by name and address. So for example, here if we assign row number, what will happen? This row will get 1, 2, 3, next 1, because we are grouping by name and address. Next for these two, 1 and 2. Once we have those kind of row numbers assigned, what we can do is we can delete all the rows whose row numbers are greater than 1. That is what the initial solution that I had in mind, and I presented it, but he wanted me to write a pseudo code in Notepad++. He doesn't want me to actually run the solution, so I wrote the solution like this. Now let's quickly see this solution. That this is the table, and this is the data that this table has. And what did we discuss? We have to write some logic where we will assign row numbers. Now this is the same table. I'm writing the row number logic. Select all comma row number over partition by name and address. And where the thing is, in deletion, whatever the row number logic, we cannot write it here in from class. We will have to write whatever the logic that we have in where class. So when I write that kind of logic here, I have to establish the connection between this reference table and a target table. This is the way that I chose, where reference.name equal to target name, address equal to address. Now once this row number logic is done, what is the outer logic? Send those rows whose row number is greater than 1 for deletion. So that is the summary of whatever that we have written here. And keep in mind, whatever the table that is here is same as same table here. We just aliased it with target and reference. Now we'll properly see how this logic is being translated. Target table, reference table, data, and this connection is there, right? What is this connection where reference name equal to name and target address equal to target address? So each row will try to have connection with the row that matches. So each row matches with 3. So 3 into 3, 9. Here also 2 into 2, 4. 1 into 1, 1. This is how compiler sees. Now, what is outer logic? Send those rows whose row number is greater than 1 for deletion. Now, once this is established, we have row numbers and greater than 1. All these will be sent for deletion. Now, once that happens, what are we ending up with? So we are ending up with only one row. Let's see if the solution actually works or not. The solution actually works, but during the interview I did not know. I just presented it, and I was expecting much scrutiny from interviewer, but interviewer just said, that's a good solution, we'll move on. I was actually surprised there. So I came back and wrote this logic, and seeing this, I was even more surprised. I was expecting the solution not to work. The reason is, let's have a dummy column for the sake of discussion. The question is still the same. Delete duplicates based on name and address. Once we have data, let's establish the connection and see how compiler sees the data. Compiler sees our logic. So we have A. This arrow will establish connection with ABC, B with ABC, same. This is how the resultant set will be. What are we asking here? We are asking here like delete, do not delete this arrow because its row number is 1. And next, again we are asking it to delete this arrow. At the best case scenario, it should have raised an error because we are asking it not to delete here and delete here and delete here. So at least it should have chosen either delete or it should have raised an error, but it did neither. It worked as expected, and the remaining things are fine because anyhow those row numbers are greater than 1, they will be up for deletion, and we'll be left with A. That is what I had in mind, but this suspicion was there. What is going on here? Let's actually see that how what is going on here. Now, before running, what is our expectation? This connection is established, all the rows are greater than 1. A will be the only thing that will be remaining. Let's see the output. What I did is just added this dummy discussion sake column that I was talking about before. Run this. We are expecting A right here. We are expecting A to be the one which should be left alone without deletion. But C is coming. It's not just A or C. Even here, we were expecting E to be left alone, but F is being left alone. Why is this happening? So try to think why this is happening, and let's see this difference between truncate and delete. We all studied this. We all studied what is the difference between truncate and delete. There is one main point. The delete statement removes rows one at a time. When I first studied before this interview question, facing this interview question, it did not make much of a difference. What does it matter if it deletes one row at a time or takes the complete chunk of data which satisfies the logic that was given and deletes all at a time? It's fine. It doesn't make much of a difference as a developer until this question. So just keep this in mind. The delete statement removes rows one at a time. Keeping this point in mind, let's try to see what is happening. A row. So compiler sees, okay, A, user has not asked it to delete, fine, I will not delete. Next comes to this. He has asked me to delete, so I will delete this. So it deleted this row. Deletion happens one row at a time, right? So once this row is deleted, the compiler tries to again re-execute this the logic that we asked again with the remaining data. So A has been deleted. And what is the remaining data? B and C. B and C, these are same tables, target and reference. So B and C are left. Again it tries to establish the connection. We have only two rows, 4. So B will be B will try to connect with this BC, C will BC, and again row numbers. It comes here. What is user asking? Not to delete this B row. Fine, compiler doesn't delete. Comes to this. User is asking this B row to be deleted. It deletes this again. And it sees the data like this. Again tries to establish the connection with the whatever the data that is remaining. C, D, E, F. Again C, C. Now what is user asking? Row 1 don't delete. Again come here. D, row 1 don't delete. E, row 1 don't delete. E, this has row number 2. Delete this. If E is deleted, this is the resulting data, CDF. Once with this resulting data, again it tries to establish the connection, CDF, CDF. Now all the rows are having just one row number. It sees row number 1, fine, don't delete. Row number 1, don't delete. F, row number 1, don't delete. So that is what we are seeing, CDF instead of A and A, D and E, we are seeing C, D and F. That is the reason why we are getting this solution C, D, F. So this is one of those rare cases where uh, developer has written wrong logic expecting compiler to do something, but it worked properly anyway. So this is one of those very rare scenarios. mm, yeah, that's all for this video. Thank you.